Hi, my friends. Right now, we are almost in the tip of the topic. There's a lot that we need to know, but everything will be worked upon if you are really taking the mastery part of which, just get up the concept and the knowledge that is underlying the discussion here. Now, what we have is just like phased application of the laws of logarithms. We have got another set of problems that we need to expect as students. And this is also featured like a lesson on its own. Right, now, without wasting time, can I have those problems now written on top here to say if we need to apply laws of logarithms only by that, what we have done, we are saying not necessarily true that it's always direct as such. Let us also look at a different angle of which. Right, so here I have got some examples, right, where we are asked to simplify, of course. Right, first one, we need to simplify log of 32 over log of what? That is a 4. Right, secondly, I'll write it, the other one. So first, because of the space, let us write 1, and then we work out on it, and I'll bring the other one. So here we are given this expression where we are dividing log of 32 by log of 4. Right. So how to work out on this? I'll first of all going to explain the common errors that most of us students do. Like in this case, we might be considering of what we're doing in algebraic fraction, where we just cancel up the word, talk of the common factor, thing like that. Like say for example, I've got a b over say maybe 2ab over talk of 4 a b squared. I'll find myself the 2 here 1, 2 here 2, a here 1, a here 1, b here 1, b here b, and the end I say the answer is 1 over 2b. That's what we know about the algebraic fractions. So this is also a fraction. So it's more like a logarithmic fraction. So what we're saying here, this type of operation cannot be done direct as it is. It is not on in logarithms. Mistakes are made such that when you check, you prove that one out, you find that that is not true about what you have got. Right, so what is it we do? Or maybe before we think of doing this, what we have done here, something has to be done into that fraction. Right, so I want you here to pay heed. You don't have to come and say log cancelling with log, and you say 4 here 1, 4 here 8, and you say the answer is 8. This is long. We don't work like that. So I know that is a common error. Most of us have that one. So first, let us polish our brains. Right. So what is the right way of doing it? Right. So I'm going to rewrite that one and then work out on it correctly. Log of 32 over log of a 4. This is one expression. This is another one expression. Unless these ones are the same, then we can cancel that and that. That's what is here. So this is log of 32, this is log of a 4. You can't cancel log and the log 4 and the 4. It doesn't make sense at all. It doesn't make sense at all. But that we could do here is just like now coming up with the common factor that can cancel each other in this case. Like say for example, the moment you have got log of 32 here and here log of a 4, by the laws of logarithms, you'll be able to do something to that, such that you should be able in the position to be able to simplify with the common factors as such. So what is required here is just a matter of looking at each expression, numerator and denominator, one at a time, and take them into the laws of logarithms. What does the laws of logarithm say? And then from those, you'll be able to get an idea on how best you can handle this. Like say for example, if I can consider log of 32 by the laws of logarithms, I'll be able to take that this logarithm of a number 32 is of that category whose bases are not indicated. And this again is a term of the part and parcel of the logarithmic laws whose bases are not indicated. So what I will do here is just like a matter of trying to make it possible. What can be the common factor that can cancel with this one and that? As remember in the algebraic fraction there, when you have got something like x squared minus x, and here you're dividing by maybe to go x minus 1. There's no way you can say x here and that x there and x that one. No. But what you do here, you're going to factorize so that you have to have entire expression that can cancel with x minus 1, and on top we have also to say x minus 1. So what you do here, you factor that one and have x like that, then x get there x and then minus 1, and down here you have got x minus 1. So you'll be able to cancel x minus 1 and x minus 1 like that, such that the answer you get here is x. So I'll be applying that knowledge. So I'll be getting towards that direction. That's why here I'm applying the laws of logarithm. I want to introduce something that is a little bit closer to what we do in this type of situation in the algebraic fraction. Right, so now what is it that I'm going to do? If I look at 32, I'll be able to realize that this 32 can be expressed to the same basis as with this a4 here. Or in short, what I'll do is I'm going to express 32 and a 4 to the same basis. That's what I'm going to do there. So if I would consider 32 and a 2, what base can I use for 32 and a 2? I found that for 32 and a 2, 4. So 32 and a 4. These two numbers can be expressed the same base, which is a 2. So like in this case, I may write this one as the log over what? 2. I'll ask myself, how many 2's can give me 32? I found that I've got 5 2's that give me 32. So it means I've managed to express 32 to base 2. Can I manage again to express this 4 to base 2? I found that that is also true. That is to say, 4 is as good as writing logarithm of a 2 to the power 2 as such. So that's what I would do. Because the direct operations, you're just cancelling this and this and that and that. That is not correct. It's an error. Right. But what are we supposed to do? Think further as a mathematician. If that is that's an error, what should I do? So the thought about these logarithmic problems, you always have to be rescued by the laws themselves. So that's what I could do. You find that what I have now is this and this for the numerator and denominator. Now what? Having done this, I'll go back to the same laws. I found that the third law without the basis, which is defined as the logarithm of maybe talk of x to the power y. Remember when you write something like this is as good as writing logarithm of x to the power y to base a 10 here. This is already a base. Such that this qualifies that this y should come here. So it means y comes now as the coefficient of logarithm of x to base a 10. But now 10 is not indicated. So it's as good as here I don't have a 10. So if I write log of x to the power y, this is as good as having y multiplied by log of x. Y comes as what? The coefficient. Considering the base is what? Is a 10. So let's now take that, say, instead of having y, we have what? A 5. So if y is the coefficient of log of x, then definitely here I'll have a 5 log of a 2. And again here I'll have a 2 log of a 2, like that. You see? So now here if I can look at this one, now this is the time when I can do those operations of cancelling the numerator and the denominator. So now here it means 5 multiplied by log of a 2 and 2 multiplied by log of a 2. So here is right to cancel log of a 2, cancelling log of a 2. Such that this gets into this one once. At the end we have got 5 over 2, which is as good as writing 2 and then what? And half or 2.5. Right, so you can see what is here. Don't cancel directly this and this and that one. But getting the laws of logarithms, you have got laws which have got no basis, and you operate as those laws which have got laws of numbers which have got basis as such. So that's the way we do. So try at least to think along this way. It's a matter of just like thinking. You can also come up with a different way, but it should not be the method that violates the laws of mathematics or the laws of what? Logarithms. Right. Now let's go to example B. Example B is given as it's also just like a direct one here, but in a different way. Log of 81 plus log of a third divided by log of 27 subtracting log of 1/9. Right, further application of the laws of logarithms. Now, as it is here, I have also hope that somewhere, if I were to give you this one as an exercise, I know some of us would have come up with the solution. The moment I've just opened you, by this, you'll be able to understand that now, you'll be able to understand on what you can do on this type of a problem. Right, so as it is presented here, the first thing we do is think about the laws of logarithms. Look at the numerator, expressions, the numerator, and the expressions, the denominator. Here I've got log of 81 plus log of 1/3. This is captured directly into the laws of logarithms, which base are not indicated. But the issue is about what? Addition. And we know that the base obviously will be a 10 is a 10. So obviously, what do you expect? You expect that this should be multiplied by this. And the denominator, you do the same. This one is subtracting this. Yes, bases are already the same here. It's base 10, it's base 10. Natural logarithm of numbers. What do? You just divide this by that. So what is it we do now from what I've just explained in the light up? So it means the numerator will have log over 81 multiplied by 1/3. And down here we have log over 27 divided by 1/9. Right. Then what? 3 here, 1, 3 here, 27. Look at that. So it means what we have the numerator there is log of what? 27. Over. Here you are dividing this by this. What you have? 9 here, 1, 9 here, 3. So it'd be like, let me come back on this part here, on down here. We are dividing, that is the 27 divided by 1/9. You come and maybe work it somewhere here, if you can find some problems. 27 divided by 1/9. What do we have there? It means I've got to invert that one, should be on top. 27/1 multiplied by the talk of what? 9/1 as such. So what you get at the end, it'd be 9 times 7, 63. 9 times the talk of the 2 is 18 plus 6, that is 24. So at the very end down here, you have log of what? That is 243. That's what we have there. Right, just by laws of logarithm. I repeat, we are subtracting. Bases are the same, it's base 10, base 10. We are adding base 10, base 10. Multiply that by this one. Divide that by that one. We have written like that one. We have divided like that one. Get this one out. The same instructions comes in. You don't have to cancel log and log, and then 27 here, 1, 27 gets in that part. No, you don't have to do that. But do as I indicated earlier. Find or identify a base to be represented by 27 and a base represented by 243. So if you look at this one, if you are going to identify a base for the two numbers, 27 and the 243, you'll be able to find that the 27 and the 243 can be expressed to the same base, which is a 3. So like here, this can be expressed to be a 3, this one again to be a 3. You'd find that we are expressing 27 to be a 3, we'll have 3 to the power, that is what? 3. Right, it's more like 3 times what? 3. You get 27. But now coming to 243, that one is also, if you are trying to fix this one to be 3, if you know it is not very easy to find how many 3's can give you 243. Sometimes you can like say begin by 3, multiply by 3, you get what? A 9. Times 3, you get what? 27 times 3, you get what? That's what? 81. So 81 times 3, you get what? Just like 81 times 3, you get 243. So you have got 3 times 3 times 3 times 3 times 3. How many are they? 1, 2, 3, 4, 5. So it means we have got 3 to the power 5 as such. Right. So from there, where do we go? We just follow the same laws of indices. This is logarithm of 3 to logarithm of 3 to the power 3 is as good as logarithm of 3 to the power 3 to base 10, and again here to base 10. So here it means obviously the 3 will come to this side. You take the position as the coefficient of log of the 3 to have 3 log of the 3, and down here it means 5 will also be the coefficient. So here it be 5 log of the 3. It goes like that. And at the end, you could try to cancel log of the 3 and log of the 3, 1, and here you are remaining with 3 over 5 as your answer. That's the way it goes. Right, so here, thus it is about it. There are many problems that you can be able to work them out. So let me also give you just an exercise where you can channel yourself through and be able to apply what we have just done here within the laws of logarithms. Right. The trial exercise, I'll just give you 2. Right. 1. I want you to work out on the following. You need to simplify this. Log of that's 8 to the power 5 to base a plus logarithm of 8 to the power 3 to base a over log of a to the power 2 to base a plus log of 8 to the power negative 3 to base a. Just 1. I think 1 is enough, not 2. 1 is just enough. Right, because I've already given you several examples for practice in order just to make you be familiar with the what? Laws of logarithm. What is here is just a matter of trying to understand the laws of logarithm. So what are they? And again, how are they applied? So what we have just done here is the issue about it in the laws of logarithms. So let me also stop here. The last meeting will be about the videos where we are going just to discuss 2 phases. 1, solving logarithmic equations. So now the question comes in the form of the equations. How can we solve the logarithmic equations using the laws of indices? And another part where maybe you may need further application in another category of the talk of the logarithmic terms. You know, this is a very extended topic in many areas, but to a level we are restricted into segments of which can be understood by your level. Right, so please let's meet again the last 2 videos that will come next in order for you to wind up the entire topic. Thank you very much for being together once again.